Hello, in this video I'm going to be starting our series on the dot product. So the dot product basically is one of the things that we have to deal with in vectors. So a vector is basically something with a force and a direction. So in a 3D plane or a 4D plane or 5D plane up to the nth plane really, you can have some vector and the length of it shows how much force it has or how much magnitude it has, which is like how powerful it is, and the direction shows where it's going. So a vector, it's commonly used in physics. It can have any number of components. Where I guess I could just say these are components. And we could also have multiple vectors. And we're going to define the dot product with we're going to notate it as having a dot right over there, much like the multiplication symbol. So from now on, when we write multiplication, we're just going to have to use parentheses, because now all of a sudden this dot represents the multiplication of two vectors. Now what is the multiplication of two vectors? We're going to write that as the summation from I equals 1 to n of xi times yi. And so this is just saying that you multiply all of the components together. Very simple. So you'd say x1, no dot over there. We could just write x1, y1 plus x2, y2 plus all the way up to xn, yn. That is what that means. It's basically a basic definition. And so it comes with a few properties, which are mostly trivial, but I'm going to write them out anyways. So one of them is that the dot of A and B is equal to the dot of B and A. If you just look at this formula, when you're multiplying all the different components together, then it doesn't really matter which side the multiplication is on because it's commutative. And then also if I do a vector A plus a vector times a vector B plus a vector C, it also has the distributive property. And you can see that by just looking at the definition, it holds most of the properties to be true. And so now I'm going to go look at a third property. If I say that I have some number C times a vector A, again, this right here, this is just a constant or a number or a scalar, and I multiply and I dot that by B. That's the same thing as doing A dot B being multiplied by C. Oh, and there should be a dot over here. Sorry about that. But that doesn't really do too much. And now our fourth property, if I do a dot of any vector times 0, if you look at our summation, it'll just be like x1 times 0, or a1 times 0 plus a2 times 0, on and on. So you're just going to end up with a 0 in every coefficient. So your answer is just going to be 0. Now for this fifth property, I need to introduce the topic of, or go further in our topic of magnitude. So I have these two lines over here. that represents the magnitude of A. And that just basically means that now we aren't taking into account its direction per se, only the length of it, how long it is, and in physics, how much force it has. So if I do the magnitude of A squared, that's going to be equal to the dot of A and B. And you can rewrite that as the summation of A squared, or AI squared from I equals 1 to N. Oh, I don't know why I put a B there, sorry. So the magnitude is equal to the dot product of the vector itself, which is equal to the summation squared of that vector. And that, I believe, is where we're going to leave off today. Thank you much for watching, and goodbye.